Very good morning, dear students. Welcome to Purnachandra Higher Secondary School. Okay. So in the previous class, we are discussing about the uniform circular motion. Clear? Okay. So in this class, we are discussing a very interesting part, that is circular motion in a vertical plane. Is a very important. It's a vertical plane. That means the path should be vertical. The paths should not be horizontal. The paths should be vertical in nature. That means with respect to plane, this structure or this path will be perpendicular. That is the vertical plane. Okay. So let us find out what type of circle or what type of characteristics it will give when an object move in a circular motion in a vertical plane. Okay. So as all of you have seen this figure, all of you look at the figure very carefully. So what happens here? What we are assuming here? First of all, let us take a object having a mass m. Listen very carefully. So let us take a object having a mass m, okay, which is in a circular motion. Which is in a circular motion. So let us take a mass m which is in a circular motion with different velocities. Look at here. This is the top position of the object, okay, and this object when it moves in a circular path, it is connected to a inextensible string. That's that string by which the object is connected, because this is the center and this is the length of the string. Listen very carefully. This is R and this is also R. Okay, so this is the center where the person you can tell. Okay, so if I will just rotate in this manner, I will tie a stone or an object with an inextensible string and I will rotate in this manner, not in this manner, because this is a horizontal plane. So if I rotate the object with the help of this inextensible string in this manner, then that becomes a vertical plane. Okay, so now first of all, before going to this circular motion in a vertical plane, we have to understand that to maintain that circular motion, okay, a force must be required, okay, and that force must be followed or must be towards the center. First of all, okay, so to move the object in a circular manner. To move the object in a circular manner, there must be a force which is radial in nature. You are going towards, okay, or applied towards the center. Clear? Center of the path, the center of the circular path. Then what the force is called? Let us first discuss. Okay, so that force is called your centripetal force. That force which hold the object during a circular motion or which help the object to rotate in a circular path, that force is called your centripetal force. Clear all of you? And because in the previous class we have discussed about centripetal acceleration. Clear? So from this or due to this centripetal acceleration, okay, due to this centripetal acceleration, the object is moving in a circular path. Because if the centripetal acceleration is absent or nil, then the object cannot move in a circular path. Very simple. So similarly, so along the direction of the centripetal acceleration, because in the previous class we discussed that the centripetal acceleration is applicable only towards the center and radial in nature. In the previous class we have discussed, okay, because during a uniform circular motion or during a circular motion we got two components of your acceleration. One is your tangential acceleration, another one is your radial acceleration. This thing we have discussed in our previous class. Okay, so now the radial acceleration which is towards the radius, that acceleration is called your centripetal acceleration. And due to this centripetal acceleration, the force we get, because according to Newton's second law, we know that where there is a acceleration, okay, then along the acceleration there must be a force applied according to the Newton's second law. Okay, force is equal to mass into acceleration, we know that. Clear? So now that force which is toward the center, along the or toward the center, not away from the center, toward the center, that force is called your centripetal force. Clear? Okay. So now let us first know about the centripetal force. So centripetal force, okay, centripetal force F, that is equal to, the formula is mass into centripetal acceleration. Okay, mass into centripetal acceleration. So mass is nothing but the mass of the object. Will take it as m. So m into what is the value of centripetal acceleration? In the previous class we have discussed the value of centripetal acceleration is your v into omega. That is simple. Okay, where omega is the angular velocity. So now m into, and we know that omega is equal to v by r. So that means this is m into v square by r. So if you will combine it, then m v square by r. So this expression what I have written here, that is the expression of your centripetal accelerations. Clear? So some of the few important points about the centripetal acceleration. Number 1 point, the centripetal force. Okay, let us know about the important points about the centripetal force. So centripetal force is always directed toward the center. Number 1. Number 2, due to the centripetal force, no work is done. Due to the centripetal force, no work is done in circular motion. Number 2. Okay, then come to your number 3. If centripetal force is absent, then the object cannot continue its circular motion. Clear all of you? Okay, so you can also take an example of centripetal acceleration, centripetal force. Okay, you can also take an example of your centripetal force. For example, the planets moving around the sun. Listen very carefully. The planets moving around the sun in a circular orbit. So to move that circular path around the sun, okay, the necessary centripetal force is provided by the gravitational force of attraction. Understood? Clear? So now to move the planets around the sun, there must be a centripetal force, and that centripetal force is provided by the gravitational force of attraction. Very simple. Clear all of you? Okay, so these things we have now cleared that to maintain a circular motion, okay, first of all we require your centripetal acceleration. Due to the centripetal acceleration, we got, okay, along the centripetal acceleration we got a force. Okay, that force is called your centripetal force, and this is the expression of your centripetal force. Okay, and this force is always applicable towards the center. Again I will repeat, the centripetal force is always applicable towards the center. Understood? So this is the fundamental things about the centripetal force. Okay, so now with this knowledge, now let us find out the different characteristics or different velocity. Okay, very simple. Let us find out the different velocities during a circular motion in a vertical plane. Let us find out. Clear all of you? Okay, in a vertical plane. So now what are the things we are going to find out in this point? So what we are assuming first? Now we are assuming that a object, okay, attached to a inextensible string. That is not the string. This should not be extensible one. That is an inextensible one. Okay, if it is extensible, then the radius or the length may be very simple. So if it is inextensible, then the your length of the string becomes fixed always. Clear all of you? Okay, so now we are assuming that, let us take a object M having mass M, which is attached to an inextensible string and which is moving in a vertical plane, which is moving in a circular path in a vertical plane. Clear? Okay, so what are the things we have calculated? Now we have calculated the velocities. Clear? First of all, we have to calculate the velocity as the topmost point A. The next we are going to calculate the bottom point B, the velocity. Okay, and next we are going to find out the velocity at point C, that is midpoint in between the topmost position and the bottom position. Understood all of you? Clear? Okay, so these things, that means we are going to find out the velocities at A, at B and at C. This is our aim. Okay, so we have to find out the velocities at point A, at point B, at point C. At point A means at the top position, when the object is at top position. Okay, and we are going to find out the velocity at the bottom position at B, and we are going to find out the midway position. Understood all of you? Clear? So let us find out one by one. First of all, let us find out the velocities at point A, topmost point. Clear? Clear all of you? Okay. So very simple. Now, first of all, to maintain, listen very carefully, to maintain the object at a point A, that means topmost point, clear, there must be a minimum velocity. There must be a minimum velocity exists so that the string cannot be slacked down. Cannot be slacked down or fall down. Because if this minimum, suppose the minimum velocity is v1, then if the velocity is reduced from v1, then the string becomes slacked down. Clear? It will not hold here at the top position. So let us find out what is the value of v1. Clear? Okay. So that means that minimum velocity with which the string can persist at the topmost position and it should not be slacked down, that velocity is called your critical velocity or minimum velocity. Okay, so now this, look at here, now this, at this point, okay, at this point to maintain this object, a force is applied. As I have already told you, a force is always applied toward the center. That force is nothing but your centripetal force. Clear? And this centripetal force, listen very carefully, this centripetal force is provided by partially by the weight of the object mg and partially by the tension in the string. Again I will repeat, to maintain the object at this point A, we are going to find out the minimum velocity v1. Okay, at this point a force is applicable. A force is applicable, okay, towards the center. That force is nothing but your centripetal force. Okay, and this centripetal force is provided partially by the weight mg and by the tension in the string. Okay, these are the two forces applied at the point A on the object. Clear? So when the object is at A, when the object is at A. Okay, so what are the forces? Listen very carefully. So the forces, number one, okay, number one, weight mg is downward. Okay, so at the topmost position, let us find out what are the forces. Okay, so the forces, one, look at here, the mg weight becomes downward, mg downward. Number two is your tension, okay, T1 also downward. Clear? So these are the two forces which balances the necessary centripetal force. Clear? So let us find out the equation here. So what I can write down here, we can compare it, that is T1 plus mg is equal to mv square by r. So that implies T1 is equal to mv square by r minus mg. Very simple. Clear all of you? So this is the tension at point A. Clear? Okay. Now at point B, this is at point A. Now at point B. Clear? So at point B, let us find out what are the forces. Number one, let us find out what are the forces. Clear? Okay. So what are the forces? Look at here. mg, number one weight mg is downward, okay, and number two, look at here, the tension T2 becomes upward, so the tension T2 is upward direction, clear? So the tension T2 is here in the upward direction, clear? So that means we can find out the equation as that is T2 minus mg is equal to mv square by r. That implies T2 is equal to mv square by r plus mg. Clear? Okay. So now these are the two equations. This is the tension at point A and this is the tension at point B. Clear all of you? Okay. Now one by one we have to find out that is. So these are tension we got. Okay. Now first of all we have to find out what is the linear velocity at point A. Clear? So let us find out what is my linear velocity at point A. Clear? So let us find out the linear velocity. So let us find out here. Okay. So the velocity at point A. Clear? Okay. So how could you find out the linear velocity? Just I told you that the minimum velocity is the v1. So we have to find out the v1. Okay. This v1 is the minimum velocity, so that it should be maintained here. Okay. And these strings should not be slacked down or pulled down. Clear? Because if the v1 velocity from the v1 velocity it will reduce, then the tension becomes 0. The tension vanishes. Clear all of you? So let us find out what is my equation. My equation at point A is this one. That is, what is my tension? T1 is equal to mv square by r minus mg. Very simple. Clear? Okay. So first of all, look at here, to maintain this tension, clear? To maintain this tension, the velocity v1 should be maintained. Clear? If the velocity v1 should not be maintained, then your string becomes slack down or fall down and the tension becomes 0. This is the condition. Clear? So let us find out the tension becomes 0. So tension becomes 0. So that is equal to mv square by r minus mg. Clear? So that implies mv square by r is equal to mg. Okay, so m cancelled out. So what is my minimum velocity? This is your v1. So let us put it here v1. So that means v1 square is equal to rg. Okay, so that implies v1 is equal to root over rg. Clear? So these velocities should be maintained by the object at point A. Okay? To not to become slack down. Not to become slack down. So this is my minimum velocity, or not to become pulled down. Okay? So this velocity that is root over rg should be maintained at point A. Understood all of you? Okay, again I will repeat, if I put the tension becomes 0, then you will get the minimum velocity v1 is root over rg. That means you have to maintain this minimum velocity at this topmost point. Clear? At this topmost point. So that the string should not be collapsed, or should not be slacked down, or should not be fall down. Understood all of you? Clear? So this is your at point A, the velocity at point A. So let us find out the velocity at point B. Let us find out the velocity at point B. Let us find out what is the velocity at point B. Okay, so let us find out the velocity at point B. Velocity at point B. Let us find out what is the velocity at point B. So to find out the velocity at point B, listen very carefully. So to find out the velocity at point B, okay, we have to apply the conservation of energy. We have to apply the theorem of, or the concept of conservation of energy. Clear? So now listen very carefully. Now the object is at point B. So the minimum velocity maintained at the point B by the object V2, so that the object is safely reached to point A. Because if the V2 velocity should not be maintained, if the V2 velocity cannot be maintained, then the object cannot reach point A perfectly. It will not have any circular motion directly. Understood all of you? So that's why at point B the object should have the minimum velocity having V2. This should be maintained. Clear? So when the object is traveling from the bottom position to topmost position, listen very carefully. When the object is traveling from bottom position to topmost position, what is the vertical path it will cover? The vertical path is AOB. This vertical path it will cover. Okay. So what is the value of the vertical path? The vertical path value is R plus R, that is 2R. Okay, so when the object is going from the bottom position to top position, because this is our reference point, we are starting from here. Listen very carefully, we are starting from here. So that's why it is moving from this to this. The vertical path covered is R plus R, that is your 2R. Okay, clear? So now we have to apply the conservation of energy. So what are the conservation solutions? By conservation of energy. Okay, so what are the conservation of energy says? What the conservation of energy says? The conservation of energy says that the total energy at point B is equal to the total energy at point A. That is simple. Okay, so total energy at point B means kinetic energy at B plus potential energy at B is equal to kinetic energy at A plus potential energy at B. That is clear. So that implies the kinetic energy at B. Simply I can write down how much? Now half m v2 square plus. What is the potential energy? Because this is the starting point B. We know that the potential energy is your mgh. Yes or no? The potential energy is your mgh, but h is your starting point. So what is the value of h? It becomes 0. So that's why this value becomes 0. Clear? So no need to write this one. So that's why this value becomes 0. That is equal to. Okay. So now it will cover this path and reaches at A. So what is the kinetic energy? Half m v1 square. And what is the potential energy? Mgh. H means what is the H? The path A of B. That is your 2R. Understood? The path. This is your H now. Starting from here, going to this. So R plus R is 2R. Okay. So that implies. So I am cancel out. So what I can write? V2 square is equal to V1 square plus your 2RG. Okay. So now that implies V2 square is equal to, what is the V1 square I will get? The V1 square is equal to RG. Look at very carefully. The V1 square is your RG. V1 square is RG. Okay. So now let us put. So this is your RG plus 2RG. So that is your 3RG. Clear? Understood all of you? So this is your 3RG. Understood? Okay. So V1 square is equal to this much. Look at here. So this means, look at here. So this is half, this is half. So this is I have to multiply it. Okay. So this is your. Okay. So slight modification there is. So this is V square plus 2RG, but this 2RG must be, again I'll write it down. Okay. So look at very carefully. So this is your half mv2 square. This half will be there, na? The half should be cancelled, means you have to multiply at 2 here. So that is mv2 square plus 0 is equal to mv1 square is equal to 2mv2. Then you will cancel the half. Okay, so that implies the m cancel out. So that is v2 square is equal to v1 square plus 4rg. Now answer cancelled out. Now v2 square in place of v1 square I can put rg plus 4rg. So that is your 5rg. So that implies v2 is equal to 5rg root over. So this is the minimum velocity at point this. So listen again, I will repeat. To cancel out this half, you have to multiply it 2 here. Okay, this is multiply it 2, and this is multiply it 2. So that the half will be cancelled out. So you have to multiply it 2 on LHS and RHS. Clear? So that you will get this equation, and v2 is equal to root over your 5rg. Clear? So this is my minimum velocity at point A. This is my minimum velocity at point D. Clear all of you? Okay. So now the lastly we have to find out what is my velocity at my midpoint. Let us find out the velocity at midpoint. Okay. So let us find out the velocity at C. Okay, so look at here. So this is my midpoint position. When I will go from the bottom to top, you will place the midpoint position at C, where the minimum velocity should be maintained v3. Listen very carefully. So when the object is moving from this to this, how much vertical distance it will cover? R. Very simple. How much vertical distance it will cover? R. That means here also we have to apply the conservation of energy principle. Clear? So by conservation of energy, what I can write? The kinetic energy at B plus the potential energy at B is equal to kinetic energy at C plus potential energy at C. Very simple. Okay, so let us find. So this is kinetic energy at point B is your half m v2 square. Okay, what is the potential energy at B? Simply 0. Just I have told you, because this is my reference point. That is equal to kinetic energy at C. Now half m v3 square plus what is the potential energy? Now mg h is your vertical distance is your r. So mg r simply. Okay, so now again we have to complete. So what we can do? We have to multiply 2 on both sides. Same process. So this is half v2 square is equal to half, that is m v3 square mgr. Now, so these two to cancel out, m. So you can write v2 square is equal to v3 square plus mgr. Very simple. Clear? Okay. So now that is equal to, so v2 square is equal to v3 square plus mgr. Listen very carefully. v2 square is equal to v3 square plus mgr. Okay. So what we are going to find out? Now we are going to find out this is your 2gr. Okay. So we have to find out this v3. So v3 square is equal to v2 square minus 2gr minus 2gr. Okay, so now we have to put the values of v2 square. Already we have get what? Now 5gr v2 square minus 2gr, so that is equal to 3gr. So that implies v3 is equal to 3gr. Clear? So listen very carefully. So at point A, you will get how much value? Now root over gr is equal to v1. At point B, you will get v2 is equal to root over 5 5gl, and at the mid position you will get V3 is equal to root over 3cl. So these are the conclusions. These are very important. Okay, these are very important from the your competition, exam competition point of view, from the JENA. So this derivation is very important. Okay. So now for this session is okay. Next we will discuss more about the circular motion. Okay. Thank you so much. Have a good day.